Hi, welcome. In this video, we will solve problem word search asked by companies like Amazon, Microsoft, Apple, and Bloomberg. Now let's solve one more problem on backtracking, that is word search. Okay. So this is again one of the common problem around backtracking. If you solve this problem, lots of your doubts will be clear. Okay. So it's a bit of different version that we have solved in combination sum, but I hope by solving combination sum you are getting some insights basically what backtracking is. Okay, and this will also clear your all the different doubts variation. Okay, this is again one of the new taste around backtracking. Let's see. So we have an m cross n grid of characters board and a string word. So basically we have this board. Okay, this is the board and we have one word. Okay, we need to return true if word exists in the grid. Okay, and we need to return false if it is not exist. Okay, simple. The word can be constructed from letters of sequentially adjacent cell. So you can see this word, basically word can be constructed by sequentially adjacent, right? This is also adjacent for this cell. This is adjacent, this is adjacent, this is adjacent, this is adjacent. Okay, cells are that are horizontally and vertically. That's why I have chosen this one horizontally, basically this horizontally and vertically, not the diagonally. Remember, not the diagonally. I can't select B, I can't select E, this D. The same letter cell may not be used more than once. That is also one important thing, that if you are using B, you can't use it again. Okay, so let's try to understand first of all input and how output is coming. So I have this word A, B, C. This is B, C, and E and D. Okay, this is my word. Okay, and if I start by here, right? Suppose if I am start by here, so I will take A, then I will move here. I will take B, and then I will move here. I will take C. Then here we are getting on C. Then here we are getting E, and this is D, right? So basically this will create my word A, B, C, D, E. Okay, so yes, I will return true. Similarly, if I talk about this one here as well, you can see I want to create C. So if I am starting from here S, I will take S, then E, then this E. Okay, so this will create basically C. So now let's solve how we can approach to this problem. Okay, how we can start solving this problem. So let's move to the board. So first of all, let me create the input of it. So let's see, this is my board. Okay, and let me take the word. The word is same word, that A, B, C, C, E. Okay, so basically how we can solve this question. Okay, I will start from each letter, right? A, B, C, E, and I will try to form this word, right? Basically this will be our thinking. I will I will try to form this word. Okay, now I have four directions, right? I can go vertically up and down, and I can go horizontally right and left. Okay, so if from each character, right, I have four possible ways to go, right? Like this one, this one, this one, and this one. Similarly, from here, I have four possible ways to go. Okay, so are you getting a sense of it? Basically, we will do four function calls, right? This is going to be a one function call. This is also this. There will be four function calls from each word. Okay, so yes, we are going to do four function calls. So let's in the starting, let's suppose if I have my function, okay, that is starting from I comma j. Okay, again in starting, that's a basically a rough scenario. Okay, so my four function call will be, suppose this is my I comma j, right? So if I am going at the top, it will be I minus 1 comma j. Similarly, at the down, I plus 1 comma j, right? Similarly, if I go here, it will be I j plus 1, and if I go here, it will be I j minus 1. So these are the four function calls that I will do. Okay, so basically as of now, I can simply write I minus 1 comma j. one function call, then second function call will be I comma j plus 1, then third will be I plus 1 comma j, and the fourth function call will be I comma j minus 1, right? These will be my four function calls, right, from each cell. So basically what I will do, I will try to figure out, right, is it possible to create a structure like a b c c e d from here? Is it possible from here or not? So I will check it from each cell, right? So basically from this we can understand that we will be traversing through complete cell, right, through each cell of the matrix. So yes, that is true, because you don't know where it can be, right? The same, suppose I want to form this d double e. Okay, if I want to form this, I will check, is it here? No. Is it here? No. Is D is here? No. D is here? No. Because I will first start with D. I will call the function here. 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 Here it is. So I will start from here. Right. I will check, is it at the up? No. Is it at the here? E is here? Yes, it is. Then I will simply go in this direction. Right. So basically I will be starting from I to N. Right. And 1 j, that is starting from again 0. I will start from 0 to end, and what we will do, call this function, right? Whatever this function is, I will call this function with I comma j. Okay, so are you getting these things, right? So now let's see, basically we are clear with few of the things, right? There will be four function calls, right? And we need to traverse to each cell by the by the basically our for loops. Okay, now let's see how we are going to solve this problem. Okay, let me again create a copy of it and let me put it here. Let me quickly fill it. A B C E S F C S A D E E. Okay, so now you have four function calls and you have this is your basically word. This is word. So let me put this as well. So we have A B C C E D. So what I will do, let's start. Okay, I will do one function call that will be here. Okay, so I can't move here, right? So I want some boundary condition so that I won't get out from the grid. So yes, there will be some boundary conditions needed. Okay, so boundary condition, I will simply come back. So that means here I cannot move, here I cannot move, right? So I will suppose I will check this one, right? And suppose here is 0, 1, 2, 3, 4, 5. First of all, I have checked that this character is at A. So yes, that is true. Okay. This is at A. That is true. That is fine. So what I will do, I will move my I pointer. Okay. And I will check, is the next character is matching. So here we have B and here we have S. So that is not matching. So what I will do, I will return from it. Then I will do one more function call and I will check, is B character is matching? Yes, it is. So this is matching. Right, so once it is matching, okay, what I will do, I will move my I pointer here, right? And again I have four function calls, right? 1, 2, 3 and 4. Now let's see, can you move here? No, boundary conditions. Now see, can you, if you are moving here in the down, right, you are getting F, but you want C, so what you will do, you won't move here, you will return from it, right? Here, what about here? Will you move it here? Okay, let's see. Now understand this scenario. Okay, let me create one more example for it. Okay, and we will get these things. Suppose you have A and B. Okay, and either here is we have C, D and E, F, G, H. Okay, and let's understand by this one only. And you have this word that is ABA. So if you have ABA, is it there in the grid? Is it there in the matrix ABA? No, we have A and B. Okay, but if you are simply moving in the fourth direction, there is one error, one possibility of error, that you can't move it here, that is fine. You won't move it here because here we have E. Okay, what you want B, so you will move it here. Now you can't move at the top, you can't move at the here because here we have F. You can't move it here because here we have C. But when you will move here, you will get A, right? And you will say that yes, I have found AB. So basically you are using the same character twice, and that should not be happen, right? That is given in the problem statement. You can't use the same character twice. Okay, so the answer for this one should be false, but if you are going in the 4 direction, you will say it is true. So what should we do? What should we do so that we won't use the same character? So what we will do, whenever, okay, what was present here, A, B, C, D, E, F, okay, whenever I will move to the next function call, what I will do, I will change it. I will change my A to some new element, suppose hashtag. So that when I will call this function, there will be an hashtag, there will be a different character that won't match with the A. Okay, so whenever we are moving, I will put simply one new character, that is hashtag. Okay, and I will move ahead. So suppose I got B, and if I am, suppose here I am not moving, but if I am moving to C, what I will do, I will simply put hashtag here as well. Okay, so now suppose you moved to here, that is C, okay, and you get to know that here you are not getting the results, right? So what you will do, you will come back and you will come back. But there is one problem. Now you have not find out the answer, okay, and you have simply changed your characters hashtag. Okay, suppose I have something as here F, right? And I want to form BA, or suppose FAB, something like this. FAB, Fab. So now you have changed my characters. I can make it right FAB, because suppose here if it is F, suppose here it was A and B. So I can make it Fab, right? But what you have done, you have simply changed A to hashtag and B to hashtag. Now this will affect my results. So see, whatever you have done, you need to undo the change, and that's what backtracking is. Backtracking, the meaning of backtrack is that you are returning to that state of the function call. Returning to the state of the function call. Okay. So basically, if you have changed some A characters to hashtag, okay, okay. So what you will do, you have changed hashtag and you have moved ahead. So once you come back, what you will do, you will again change hashtag to A. You need to do the undo all the changes, right? Whenever you are returning from it, because suppose if you in that path you are not able to find the answer, you will change it to the same character. Okay, and we will learn how we will do it. But I hope you are getting these things. First of all, few of the observations that we got, that we want boundary conditions. Okay, and if the character, like I will simply match with the character, so here I am getting A, here I am getting A, I will simply move ahead. Then now here I am getting B, here I am getting B, I will simply move ahead. If at any instance, like here you are getting F, right, and here you are getting C, so what you will do, you will return from it, you will say that this is not the correct path, this is not the correct path, you will simply return from it. Okay, so this is also one of the important point that we got from here. So I hope few of the things are clear to you, right? How basically we need to move, we need to do these 4 function calls, we need to apply boundary condition. When we need to return, we need to return whenever there is a character difference. Okay, and suppose if you are reaching to this length, right? What is the word dot length? Till 6. Okay, if your index is reaching to 6, can I say that you have find out the answer? Basically you have find out this answer A, B, C, C, E, D, and then your I pointer will come to 6 now, right? So if you are reaching to the word dot length, that is 6, can I say you will return true? Because you have find all these answers A, B, double C, E, D, right? So yes, that will be our base conditions. Okay, so I hope few of the things are clear. Let me create a pseudo code of it, that then you will get few of the structure, basically what I am talking about. Okay, so now we can talk about the pseudo code. So let's see. So let's create our function. So I'm naming my function as DFS. Basically, whatever we are doing, it's DFS, depth first search. You will learn this concept in graphs. Okay, depth first search. Okay, so I'm writing name as DFS, and this is basically I will take my board. Okay, I pointer, J pointer, I will take the word, and to traverse in the word, I want one index. Okay, these will be the values. Okay, so remember what I will do? I will do the four function calls, right? So let's do the four function call. I have DFS, okay, same board. So I will write B. Okay, now here will be I plus 1, J, right? Same word, okay, and index will increase it because index is for the word, right? So it will increase, it will be index plus 1. Now same DFS, it will be board, then you can say I minus 1 comma J, and then we have the word, and again index plus 1 here. Okay, then we have DFS again with the board. Okay, that's a board. I am writing B, that basically that means board. So I, then J plus 1, and I will simply say word, then index plus 1. Then we have one more DFS with board, then I, then J minus 1, word, index plus 1. These will be the four function calls. If any of the function call is returning me true, can I say yes, I am able to find out? So basically, see, you are calling these function calls, right? You are calling here, then you are calling here, then you are calling here. If any of one of the path is giving you true, the whole answer will be true, right? The whole answer will be true, right? There can be different path possible, right? Like this one, this is one of the path, this is one of the path, or this can be one of the path, this can be one of the path. If any of the path is giving true, the answer will be true. So yes, we will use here or condition. Okay, because if anyone is true, I will get the true result, right? So basically I will return the result of it. So let me store this in the result, and I will return the result, return. Okay, now once we have done it, now let's apply the conditions, our boundary condition. So one will be our boundary condition if I is less than 0, or j less than 0, or I is greater than equals to n, that is board dot length. Okay, j is greater than equals to board 0 dot length because it will take the first row. So board 0 dot length, or I can say m, right? If m are columns, so instead of board 0 dot length, let me say yes m. If any of the condition is true, what I will do, I will simply return from. Okay. Now, when I will return false, I will simply return false. That means that path is not is good. Okay, you are not basically, suppose if I am at E and I am checking S is not relevant. So what I will do, I will say this path is not good. Okay, don't go ahead with this path. So I will do the same. I will simply say board of I comma J, right, is not equals to word of index. Okay, word of index. If it is not equal, simply return, right? Return false from it. So I will return false. Okay. Now what is the thing? I have said you, like, once you have moved one of the path, what you will do, you will make it hashtag, right? So what I will do, I will simply make it hashtag board I comma J equals to hashtag. Basically, so that I won't visit the same letter twice. Okay, this is basically for this one. But now you are making it hashtag. Whenever you will come from the function calls, you need to make the same, right? So what you will do, you will make it same here, whatever the character was. So what you will do, you will store that character into some variable temp equals to board of I comma j, right? And you will make again equals to temp. So whenever you will return, so let me tell you the concept of backtracking is, that is a very good concept we have seen in the combination sum. Okay, is that suppose you have, whatever you have done the change, right? Any change you have done, okay, any change or work you have done before the function call, okay, before the function call, what you will do, you will undo that change, undo the change. Okay, and one of the example is this one, right? Here you are done simply putting hashtag. Here you are undo the change what you have done. Similarly, if you can remember the previous example of combination sum, where we have done answer dot push array I, right? And when I am undo the change, what I was doing, answer dot pop. So whatever I have pushed, I was doing pop here, right? And this was the function call. So this is very important of concept of backtracking. Whatever the you have changed, whatever you changed before the function call, you will undo that change. Okay, so all these things are done. The only one condition is left, that is once your index is equals to what dot then length, that means you have reached to the end, you will return true here. In that case, you will return true. Okay, so this will be your DFS function, and now you will, what you will do, you will simply call this DFS function. Let me put this aside. Now what you will do, you will call this DFS function in each function call, basically when each traversal. So when I is 0 to n and j is 0 to m, right? In that, what you will do, you will do this function call. Or if suppose this function, basically your DFS board I comma j comma word comma index, if it is true, then you will only return true, because in that case you are able to find out the word. Or in the last, what you will do, you will return false. So yes, this will be our code of it. Okay, okay, and again this is a pseudo code, so you can understand it in any of the language. Okay, this is what we are doing. So in the next video, I will give you the code implementation of it, basically how we are going to do this. This is going to be exactly same, yes, but we'll give you basically how it is working. Okay, and basically this is the code, whatever we have discussed. So this I was discussed when I was simply taking this in this character, this character, this character, this character. When I'm reaching to the end, can I say that yes, I have reached to the end, so I will return true. Okay, now these are my boundary conditions. So here, these are my simple boundary condition. If the character is not equal, I will return false. That path is not correct. Okay. Here, what I will do a change, and I will do the undo my change. Okay. And these four function calls we discussed basically here. Okay. And I will return the result. Result will be the true of any of the things. So yeah, this will be our pseudo code of it. Now let's quickly discuss the time and space complexity. Okay. So now see what will be the time complexity of it, and that's a bit tricky, but let's understand it. Okay. So see, on each, you are traversing through each cell, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So there are, if there are total 20 cells, you will check all the 20 cells. So yes, okay. Basically, so it will depend on the total number of cells. So can I say into n cross m? But now on each cell, you are doing four function calls. You are doing four function call, and that function call can lead to the word length. Okay, that can go till word length, right? So on each cell, you are doing four function calls, but one of the function from one of the calls. See how, let me create a new one. So you have this A, B, C, E, and S, F, C, S, and we have A, D, E, and E. So on each cell, you are doing four function calls. Here. On each cell, you are doing four function call. But if you can see, in one of the function call, you won't come. And what is this one? That means you can't backtrack to the previous answer. So you won't come to A, right? You won't basically go to this function call, because you will make it hashtag, right? You will make it hashtag. Suppose you have made it a hashtag, so you won't commit. So if there are four function calls, right, you can go in this direction, you can go in this direction, you can go in this direction, but you won't come back to the to your last answer, because you have changed it to hashtag, right? So we won't commit. So instead of four function calls, there are not four function calls, there are three function calls only. Okay. So there will be basically big O of n cross m into 3. And now these 3 function calls will go till the length of it, length of the word. Whatever the word length, you will do function calls till there. Okay. So it will depend on the basically 3 power L. Okay. And that won't be a power, I guess. Sorry. Basically, that will be a multiplication, because on each cell you are doing 3 function calls, and these 3 function calls will go till the length of the word, right? Where L is basically word length. Okay. So basically, suppose if word is A, B, C, D, right? So you will go till 4, right? You have 3 function calls, right? From each point, you will have 3 function calls. Why I'm saying 3? Because basically you have 4, but you can't visit the same, right? So suppose you can't visit the same, you have 3 function calls. Now from here as well, right? You have 3 function calls, okay? Because you can't visit the same, right? So you have 3 function calls. Here as well, you have 3 function calls. You can't visit the same. So 3 function calls, and you will go till the word of the length. So it will be L. So basically this will be our time complexity of our word search. Okay, word search. Now what will the space complexity? Now see, space complexity is depends on the number of recursion call stack. Okay, here I am not taking any extra space, so I am not considering this board space or whatever. We are not creating any extra space. The only space will be of auxiliary stack space, recursion stack space. Okay, and you will see recursion stack space, okay, will go till the function calls of this L, right? So it will basically directly proportional to our word length. Again, it is directly proportional to our word length, because if there are then number of function calls, okay, that will be basically number of function calls will store in your call stack, right? So basically it will be big O of L only. So yes, that will be the time complexity and space complexity, right? N cross m, because for each cell we are doing the 3 function calls, and for these 3 function calls will go till the word length, right? Whatever the word length is, it will go till word length. And space complexity will be basically depends on the word length. If there are 4 functions, so I will call 1 function, then 2 function, then 3, then 4, and all the 4 function will be stored in my recursion stack auxiliary space. So it will be big O of L. So yeah, that's all for time and space complexity. I hope you got this problem. Okay, in the next video, I will give you the code implementation of this problem, and then we can check out the dry run, how basically it is working. Okay, so see you in the next video.